Good morning everyone, my name is Sachin. I am here to give a short presentation on my project that is Traveling Salesman Problem Model in Recovery System for the Hypermarkets. This course is led by our professor Dr. Pemberton Cyrus. It is said that a necessity is the mother of invention. So a need of a problem encourages creative efforts to meet the need and or to solve the problem. I am working in the Walmart as a sales floor executive. My major job is to do the recovery of the items, collect the item, place it at the right place, collect more, and do it in a repetitive way. So the main question is that why to travel too much if we have a minimum path for that job? Let me tell you what exactly the recovery process is. In recovery process, I should collect the product, scan it, and I must travel to the designated place to keep it. And this process goes in loop. The main question is that where should I start? Sometimes it can take more than 2 hours to complete a single cart because the products are not segregated and the process goes in loop. This is general layout of any hypermarket. So for example, if we start our recovery process from here, we may have to travel to the garden area, to the paint area, to auto care area, to grocery, any location. So there's not a fixed path. So traveling may take a lot of time. If we have a designated or directed path, the traveling time can be reduced. This is the recording of a footstep which I used to have while working in the Walmart. So on an average, I was traveling around 16,000 steps in a single day in a span of 4 hours or 6 hours. So it was equivalent to almost 12 to 13 kilometers. Traveling salesman problem is one of the most fundamental, important and well-studied problem for optimization. In spite of being NP hard, many of the special cases have been solved in the polynomial time. So what will be achieving in solving the TSP in the hypermarkets? First, it will increase the efficacy of the associates. They won't be getting tired and the performance can be increased. Second, manpower can be reduced for the same job and this will minimize the overall cost of the company. As we know, Industrial 5.0 in the present stage and robots will be replacing humans and AI will be there. So this model can be used to give logic to the robots for doing the recovery process. And this model can be used in different hypermarkets like Walmart, Sobeys and different warehouses. This model can also be used for the pickup of the items, delivery of the products from a depot with some additional constraint. So solving TSP to find the shortest route with a different product and to complete the recovery in the minimum time is the main aim of our project. I have used different coding platforms. Float Vassal has been executed in Python, and for TSP formulation has been done in Goosec using MTG constraint, and after executing the file on Goosec, LP file has been extracted and that same file has been called in Gurobi for the final execution for the TSP model. And the results and all the problem statement was successfully solved on the system that was having i7 9th generation with the 6 cores, and it has successfully solved 1000 knots problem in 318 seconds with minimum gap of 0.72%. Let's look at the result. We have successfully obtained and solved the TSP model for the 1000 nodes using the Gurobi, and we have compiled the paths using Python. So all 1000 nodes with the minimum distance and the shortest route, minimum distance with the shortest route has been obtained here. One node is like the starting node where we have started the recovery process and we have and completing the final step with the same spot. Let's look at the experiment that I have performed. First, I have used different models and platform for solving the TSP model. First, I started solving TSP in Python by using permutation and combination. It worked well for like 10 nodes, but after 15 it was taking more than 30 minutes. And for the second, all neighbor search was done in the Python code, with the Dijkstra algorithm. It worked well for the 20 nodes, but for the nodes greater than 25, it was computational time was greater than 3300 second. And the third experiment was like solving TSP model with MTG constraint on Python and Goose. For the 100 nodes, we were getting a computational time of 10.3 second. For 250 nodes, we were getting a time of 346 second, but the node greater than 350, execution time was greater than 2300 second. And again, TSP was solved using GG constraint in Python and Goose. It worked well in 100 nodes. Execution time was 122.6 second, and with a minimum gap of 1%. We can see that execution time is still greater than MTZ constraint for the 100 nodes, which was 10.3 second. So we didn't continue with the GG constraint. And the final was like TSP solving with the MTG constraint with the platform like Python, Goose and Gurobi. It successfully solved like 250 nodes in 6.97 with a gap of 0. And for the 350 node, execution time was 52 seconds with a gap of 2.5%. For 501 nodes, execution time was 30 seconds with a gap of 0.1187%. And for the 1000 nodes, it successfully solved like problem in 318 seconds with the minimum gap of 0.72%. So it can be concluded that TSP model can be executed in the hypermarket for the recovery process, and it can prove to be beneficial in improving the efficacy of the associates working in the store. At the same time, it can help in minimizing the overall cost of the company. There are different ways to solve a problem. Solving problem with the least computational time and solving the problem with the minimum gap is very important. And there are still different approaches that can be tested for finding the best optimum value in the least computational time. These are the lists of references that I have used in my presentation. I would like to thank Dr. Pimentel Saras and Jasmine for helping me in debugging the code. Thank you everyone.